1986, NCTCS had proposed February 28 to be observed as National Science Day in commemoration of the discovery of Raman's effect. And so government accepted that proposal, and from the next year, 1987, the first National Day was observed on 28 February. C.V. Raman, full name is Chandrasekhar Venkata Raman, South Indian tone, Chandrasekhar Venkata Raman. He was born to a Brahmin family in the year 1888, 7 November. His father, Chandrasekhar Iyer, was a teacher of physics and mathematics, from whom he had inspired to learn physics and mathematics. And in the year 1902, he passed his higher secondary examination and joined Presidency College to study BA. And in the year 1904, he qualified the degree, BA degree. At the time, the name of the degree was called BA with Physics, first position, gold medalist from Presidency College. And then he passed his MA in Physics in 1907 with highest distinction. In 1907, after passing MA degree, during his MA course also, he was very much interested to do research in optics and musical instruments. He is very fond of musical instruments. He wanted to go to London, England for higher study, but his father, Chandrasekhar Iyer, insisted that he, being the second son out of the 8 children, he has to support his brothers and sisters for higher study. So his father insists him to do job. Then Chandrasekhar agreed. Family comes from first, and he applied for job. At the time, Indian civil service examination was held in London. Because of the expenditure and family problem, he could not go to London to apply for Indian civil service. Instead, he applied for Indian financial service and stood first in the year 1907. And he joined Indian financial service. First posting was at Kolkata. This is the turning point of his research career, where he came across the Indian Association of Cultivation of Science at Kolkata. And during his off hours from the office, he started doing research works. And in year 1907 itself, he published a paper entitled during his MA course, he had published a paper in philosophical magazine, Unsymmetrical Diffraction Band Due to Rectangular Aperture, 1906. In 1907, in Nature magazine, while he was in Kolkata, taking up the job of Assistant Accountant General, Department of Finance at the time, he published a paper titled Newton Rings in Polarized Light. This paper was published in National Magazine from Indian Association of Cultivation of Science. And in 1918, up to 1917, he is working as Assistant Accountant General, Government of India, British India at the time, and his interest in research in physics has compelled him to resign his job very frequently. But due to family pressure, he could not resign the post. But in the year 1917, his wife, Loka Sundari, supported him, knowing his ambition, knowing his talent, because the salary of Indian financial service is very high compared to the job of teachers in that time. In 1917, he joined Science College under Calcutta University, whose salary is almost half of the salary of the Assistant Accountant General. Even then, even the salary is half because of his inclination, because of his ambition to do more in science. He has resigned the post and joined Calcutta University as Pilot Professor. At the time when he took the professor post, many universities, including Madras University, Varanasi University, they have objected to him offering the professor post because he was not a PhD or degree holder. Controversy comes after that, and Calcutta University, particularly Professor Asutosh Mukherjee, his mentor, gave him the honorary DSc degree, Doctor of Science degree, and he became the full-fledged professor under Calcutta University. And in 1980, he published the paper Maintenance of Vibration, Theory of Musical Instruments of Violin Family in the Debate of Indian Cultivation of Science. In the next year, 1919, he became the Secretary of Indian Association of Cultivation of Science. And in 1921, he was honored Doctor of Science by Calcutta University. And in 1922, he published a paper, Molecular Diffraction, from the University of Calcutta, University of Calcutta publication. Also many studies exploring the behavior of scattered light. This work conducted with his collaborator at Indian Association of Cultivation of Science, and this particular paper, diffraction of light, molecular diffraction of light, paved the way for the Raman effect, which again he published another remarkable paper in the year 1928. And in the meantime, he was awarded Fellow of Royal Society in 1924, and in 1926, he founded the Indian Journal of Physics as the founder editor. In this journal, he published the famous paper, The New Radiation. And the New Radiation was published in Indian Journal of Physics in the year 1928. For this journal, he was the editor. In the year 1928, Raman and his student, K.S. Krishnan, observed that when a monochromatic light passes through a transparent liquid, the scattered light consists of wavelengths other than that of incident wavelength. This is the discovery of Raman. From this, Raman has explained the scattering of light. Earlier, in the year 1921, when he went to London for a conference through the voyage through the Mediterranean Sea, the blue color of the ocean fascinated him, and he started thinking how there is deep blue color of the sea. If it is because of the reflection from the blue sky, which is lighter blue in color, but the color of the sea is deep blue. Earlier explanations, classical explanations from Rayleigh's theory, the color of the water, sea water, is blue because higher the wavelength, more is the scatter. It was stated by Rayleigh's law. But it is something. It is something. And C.V. Raman, taking cue from the discovery of the Compton effect, scattering of the monochromatic X-ray. And at that time there was a development in the field of the physics, the birth of the quantum science, light behaves as a particle. The light particle, photons, collided with the water molecules, and this gave rise to a different set of scattered wavelengths whose frequency is plus minus the incident frequency nu naught, which gives to Stokes lines and anti-Stokes line. And his experiment is very simple. It is indigenously developed spectrometer, just like we have in our laboratory at that time. It is indigenously developed spectrometer. And earlier he used, by multiple reflection of sunlight, he used sunlight as a source and could not obtain very beautiful result because of the poor intensity of sunlight. And in the year 1926, the mercury light was discovered. Mercury arc lamp was discovered. He procured mercury arc lamp, and the source was mercury arc lamp. And this is original paper. This is from his original paper. And in the spectrum, he got wavelengths lesser or greater, some wavelengths accompanying. These are later explained by Stokes and anti-Stokes lines. And this is C.V. Raman explaining the Raman effect, his student. And we should not forget to mention this particular man, A.S. Krishnan, third from the left in the sitting row, he is very instrumental in achieving the results for C.V. Raman, in Raman effect. And we should not forget to mention A.S. Krishnan. And this is the Nobel Prize ceremony in Stockholm, Sweden. C.V. Raman is here, Nobel Prize in Physics. Hans Fischer, Nobel Prize in Chemistry. And Carl Landsteiner, Nobel Prize in Medicine. And this is Sinclair Lewis, Nobel Prize in Literature. And this Nobel Prize, Raman was attracted to get the Nobel Prize in the year 1920, the discovery year, because the discovery was made in the month February, 20th February, and the Nobel Prize awards is during November, December. He was expected to get Nobel Prize, but however, Nobel Prize in Physics in the year 1928 goes to Owen Johnson, and 1929 it is Louis de Broglie for his hypothesis, and in the year 1930 he was very much confident. This year he will because and in some literature we have found that Lord Rutherford have helped him, and his name was nominated by Lord Rutherford for the Nobel Prize in Physics. And I want to show one very important picture. This picture is from the Associated Press of India, published in Kolkata newspaper on 29th February 1928, when Raman and Krishnan have demonstrated the success of Raman's effect in laboratory at Indian Association of Computation of Science, Kolkata. The next day, the paper published that C.V. Raman has discovered a new thing, new radiation. And Raman said this discovery is the fingerprint of the material, fingerprint for its material, for the water, because of his molecular structure, the scattered color gives deep blue because of the molecular structure. For any material, it gives the fingerprint of material. This later on, Raman's spectroscopy has developed to study the characterization of the structure of many molecules, many drugs in medicine, and many things. This is very important. This is the foundation of Raman's spectroscopy. And my speech will be very lengthy, so I will close my speech at the time when he received Nobel Prize. He has a long story. He founded Raman Institute, then Indian Academy of Science, many things. And he died in the year 1970. And his life, as we see him, unlike the other physics teachers, he is very clean capacity, he has the ability to make friends with the Western country, which most of the Indian people miss. Because of his association with the British people, his wife is also a veena player. He plays the musical instrument veena, and because of love of their music, they together went to the Calcutta church at Kolkata. Because of this, many people at that time, many insurgent groups revolting for the freedom of India are there. So they put very attraction to them. That is the theory. So Raman is the pioneer of science, the pioneer among the Indians who can mix with the world. He was the first non-white people receiving the prestigious Nobel Prize in Physics. So we salute him. We salute him today also. He is our leader, our role model, and with this few notes that we take of you all. Thank you, everyone.
Thank you, sir, for the wonderful talk on Sir C.V. Raman. And as a token of our respect and gratitude, we would like to honor him with a traditional layyan. May I request our respected HOD, Sir M. Somananda Singh, to kindly come forward and present the layyan to our esteemed speaker. Sir, please.
Apa kay audio?
Thank you, sir. Now comes a moment of pride and celebration. Hard work, creativity, and excellence deserve recognition. I request our respected guest of honor, Sir C.H. Bidyasagar, Head Department of Physics, Jain College of Science, Dhanamajuri University, to kindly come forward and present the prizes to the winners. May I now invite the winners of quiz competition, high school level, to come forward and receive their prizes. So the first prize goes to Thangjam Pangaljit Maitai, Hali English School. Please come forward and collect the prize. High School. Please come forward and collect your award. So the third prize goes to Melbourne Siren, St. Joseph Private School. Along with the main prizes, we would also like to recognize the commendable efforts of the participants who performed exceptionally well. So, we have selected 3 consolation prizes. So, the 4th rank goes to Rukaya Chesam MS Creative School. Kindly come and collect your prizes. And the 5th rank goes to Jameson Maite, Golden Valley Academy. Please come forward and collect the award. Okay, so the 6th rank goes to Sheikh Anissa MS Creative School. Please come forward. Congratulations to all the winners. Thank you, sir. So the representative of the fifth ranker as Jameson Maite, Golden Valley Academy is present with us here today. So I request the representative to please come forward and collect the award. So I once again request Sir Anthony to come forward and collect the award.
Fifth.
Thank you, sir.
I now request the President of today's function, Sir M. Somananda Singh, Head Department of Physics, Thangjam University, please hand over the prize to the winners. Here is the result of the recent quiz for the college level. So the first prize goes to Muhammad Jawad Alam, Dilong Harabi College. And the second prize goes to Mangba Siddhartha, Yale College of Science, BSc Physics Honors 6th semester. Then the third prize goes to Alan Luang, Yale College of Science, 6th semester, Physics Honors. Along with the winners, we also have the consolation prizes. The fourth rank goes to Aziz Aribam, Dilong Harabi College, BSc First Sem. And the fifth rank goes to Sunny Sawaizam, Yale College of Arts, BA Political Science Honors, 6th semester. And the sixth rank goes to Asakumar Kuman Mayangam of DM College of Arts, BA 6th semester Political Science. And the seventh rank goes to Elando Yunghai GP Women College, BSc, 4th semester. If there is any representative, okay, Ma'am Susma, please. Okay, thank you, sir. Next, may I now request Dr. Biju Thangjam, Associate Professor, Department of Physics, Bidyasagar University, to kindly deliver a talk on the topic Celebrating Pioneer, Breaking Barriers, and Empowering the Next Generation of Women Innovators for District Parliament. And please.
해보자. 부모님 가이드 보고 하기 전에 아니. 오히려 시작하기 뭐.
A very good afternoon to everyone present here. I would like to extend my warm welcome to our respected chief guest of today's function, Professor W. Chan Babu Singh, Honorable Vice Chancellor, Dhanamantri University. Respected guest of honors, Professor S. H. Birbal Singh, Principal, DM College of Science, Dhanamantri University. Professor L. Rajan Singh, Principal, GP Women's College, Dhanamantri University. And C.H. Viren Singh, Head, Department of Physics, DM College of Science, Dhanamantri University. And respected President of today's function, M. Sumanda Singh, Head, Department of Physics, Dhanamantri University. And to all the faculty members, research scholars, students of different schools and colleges present here. Today, on this 20th February, National Science Day 2026, I would like to present a talk which is titled Celebrating Pioneers, Breaking Barriers, and Empowering the Next Generation of Women Innovators for a Viksit Bharat.
The theme of National Science Day this year is Women in Science Catalyzing Viksit Bharat. First of all, I would like to introduce myself. I am Dr. Biju Thangjam, Associate Professor, Department of Physics, Jam College of Science, Dharmanjuri University. For centuries, women were denied education. They were banned from learning sciences. Women were restricted to household activities only due to the cultural norms. Yet, despite all these systematic barriers, women have contributed immensely to all the fields of science. Their perseverance, intellectual brilliance, and resilience have challenged inequalities, and this has led to the reshaping of the scientific landscape. Women scientists, they have made many groundbreaking discoveries. They have revolutionized science, medicine, space research, technology, etc., various fields of sciences. They have shaped the world through their discoveries, inventions, researches, and so on. And despite all these challenges, they have transformed our world for future generations. Here, I am showing a picture of an international conference, the fifth Solvay International Conference, where prominent physicists from all over the world are present here to discuss on the newly formulated quantum theory at that time. And most of these participants, 17 out of the 29 participants, they are Nobel laureates. And one of them, as you can see, is the female candidate, the most renowned women scientist, Marie Curie. As you can see in the front row, so the National Science Day is observed every year on 20th February in memory of C.V. Raman because of his groundbreaking discovery of the Raman effect. In 1928, he was awarded Nobel Prize in 1930. He was the first Indian Nobel laureate, and his findings were published in Indian Journal of Physics in a paper titled A New Radiation. Here is a picture in which you can see C.V. Raman along with prominent physicists. One of them is Niels Bohr sitting on his left. And this is like a storytelling, like unlike my previous lectures which I delivered on other meetings, gatherings. This is like a sort of storytelling because all the students are also school students, college students. So about my talk will be focusing on mainly women scientists who have contributed a lot to our society, from whom we can draw inspirations. They have broken the barriers and we can learn a lot from them. So one of the pioneers of women scientists is the well-known physicist Marie Curie. She is the first woman to win a Nobel Prize in two different fields, in physics and then in chemistry later on. In 1903, she was awarded a Nobel Prize in physics along with Henry Becquerel and his husband Marie Curie. And in 1911, she was awarded Nobel Prize again in chemistry for the isolation of radioactive substance radium. Here, as you can see in this picture, Marie Curie in her laboratory, on the right side. And on the left, we can see her thesis. She was the first woman. This is her thesis. She defended her doctoral thesis on radioactive substances at Sorbonne in Paris, and she was the first woman in France to receive a doctoral degree. She was born in Poland, and her original name was Maria Salomia Sklodowska. But at age of 24, she moved to Paris because studying science, higher education was banned in Poland, in her native land. So she went to Paris, France for her further studies for pursuing higher education. And there she adopted the French name Mary. Where she met many physicists who were well known. This is the picture of Marie Curie and her sister. She was indeed a very hardworking lady. She worked far into the night, just living on bread, butter, and tea. And then she began to work in Lippmann's research laboratory. You can see her working in her chemistry lab in the Radium Institute in Paris. And later on, in the spring that year, she got married to Marie Curie. You can see this picture. Marie Curie and Marie Curie on their honeymoon bicycle trip in 1895. They were so simple at that time. Then, after that, Marie Curie struggled. Their marriage marked the start of a partnership that was soon to achieve results of world significance. Then Marie Curie struggled to obtain this pure radium in the metallic state, and on the results of this research, she received her doctorate of science in 1903. Even after the birth of her two daughters, she was not deterred from her research work. She carried out her work intensively. Normally for a woman, after getting children, after living a settled life, they couldn't devote much to scientific field at the time, and nowadays also most of the women. But she is much determined. She worked really hard and dedicated much of her time to research. But the sudden death of her husband was a bitter blow to her career. Even then also, she didn't stop working. She devoted all her energy alone in the scientific work in the field of her radioactive work. She took his place as professor of general physics in the Faculty of Sciences. And in 1911, as I told earlier, she was awarded the Nobel Prize for the second time. But here, in this case, she was awarded the Nobel Prize for chemistry for the isolation of pure radium. As you can see in this picture, Marie Curie driving an automobile which has been converted into a mobile radiological unit. Very interesting. And throughout the World War I, she, with the help of her daughter, devoted most of her time to the development of the use of X-ray radiography. And One of Marie Curie's one of her achievements was to have understood the need to accumulate these radioactive sources that she had discovered, not only to treat illness, but also to maintain an abundant supply for research in nuclear physics. So her contribution is immense. Here you can see Marie Curie's notebook, her handwritten notes. This book is said to be radioactive still now. And after her death,